Okay, I think we can start. So, if you have any doubt in week 4 activity or practice question, you can ask. Hello. Am I audible, right?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So, if you have any doubt in week 4, you can ask activity or the practice question. So, if you have no any doubt, so we can discuss about the relational algebra if you have no any doubt. So, can anyone tell? My screen is visible for you. Yes or no?
Yes.
Yeah. So what is this operation? Can anyone?
This will select the tuples.
Yeah. So this is the selection operator, right? So what is the function of it? Yeah, please, at least you can try. So, whatever you know about.
It will select the value as per the select command, like select a name, address from say employee tables. So it will select the values of the name and the address attribute.
So it is basically filter out based upon some condition, right? So is what you mean, right? So
Yes, sir.
select, suppose there is one condition, X is a condition and based upon relation, right? So this is the selection of. So let me give me one example, right? Suppose you want to find the instructor whose age is greater than 25, right? So can anyone tell how to write?
Please pardon question.
Okay, I think some problem.
Pardon question, sir.
Yeah. I repeat just.
Okay.
Yeah. Just So is it visible? So find the name of instructors greater than 25, right? So can anyone tell what is the relational algebra expression for? You can at least tell what is the SQL query for.
Select name from instructor where age is greater than 25.
Yeah, that is absolutely correct. Now tell me what is the relational algebra expression? So select name instructor where age is greater than 25, right? This is the SQL query. Now tell me what is the relational algebra expression?
So sigma name
Sigma name
comma age greater than 25 and in
greater
bracket we will have instructor relation name.
instructor, right?
Right.
So let me correct you.
Mhm.
In the relational algebra expression, this sigma, we only put the condition. So what
Okay.
is our condition? That is the age.
Age.
And for here, you can see the find the name of instructor. We have to, this thing, we have to project it, right? So we extract that information. For that, we use the project,
Okay.
right?
Pi.
Yeah, pi use
Oh.
this one. So now tell me. So these things is not. So we put condition only in this sigma or the select operation, right?
Only the
And
where
then
clause will go.
here, this is the where clause.
Okay.
Yeah, we put whatever's in the where clause, we put in the select, this select operator under the select operator here, right?
Okay. So then
And
pi
whatever
name.
we want to project these things, we write here pi name, right?
Okay.
Is it clear to everyone, right? Yes or no, at least you able to
Yes, sir.
understand this thing or not? Whatever's in the where clause, so the based upon which condition we select the tuples or row, you can say. So we put that in the select and the here we put under this, means you can. So this is the, you know about it. First, let ask you, you know about this operator, right? Or shall we discuss on the deep? Okay, okay, let's discuss. So this is the this is the select operation. Select operation. This is the project.
Yes.
Uh, yeah, yeah, well, hello, someone was something, right? So this is the select operation. This is the this is the project operation. So whatever you want to retrieve from the relation, right? So suppose here you can see select name. So whatever we want to, so mean retrieve from the instructor, that we put under here in the select project operation, right? Project operator. Okay. So this is one select operator and the project operator. After that we see the set operation. Yeah.
Would you write the syntax of this projector and select?
Yeah.
What are
I
the
have
other parameters are applicable?
here you can see this thing, or you can omit this thing only when you select all the information. Suppose the question is like find all the details of the instructor. So suppose instructor table have this id, name, address, and the salary, right? Table schema is clear to everyone, right? So instructor, one relation,
Instructor is one relation, sir. Any relation can be there, no?
Yeah. I'm just telling
Okay.
with one example, right?
Oh.
So instructor, okay. So first, this is the basic structure of the select operation, right? This is the relation, and in X we put the condition, right? Whatever condition. So
Yes,
here
sir.
you can
Fine.
see age is greater than 25. So in the place of X we put that condition, and this is the relation, right?
Right.
Up to this is clear to everyone.
Yes, sir. Fine.
Okay. And pi is the project. Pi is the project operator, right? So whatever we want to project or mean extract from that relation information, so that we put in the pi operation, uh, pi or the project operator. So right. So in this question, in this example, you can see find the name of instructors whose age is greater than 25, right? So in this, the SQL statement is select name from the instructor where age is greater than 25. This is the SQL statement, right? Right. So if you convert this thing in the relational algebra, then so what is the structure? This is the structure. So pi sigma inside in the sigma, under the sigma we put the condition, right? Is greater than 25, and we extract this information from the instructor. Okay, and here you can see we want to select only name. So I already said that the for the select operation, for the you want to project something, so then we use the pi operation, right? So pi. So first you perform this thing. Then, okay, let me write this. Is greater than 25. Okay. and we select these tuples, means whichever the tuples satisfy this condition, right? So in this way, and from that tuples we need only the name, right? So that's why this is name, right? uh, are you able to follow, right?
Yes, sir.
Okay, so so the second example is, suppose this is the table schema or the relational schema: instructor, ID, name, address, and the salary. And suppose the question is, find all the details of the instructor whose age is greater than 25. So in that case, you can write pi ID, name, address, and the salary under here. ID, name, address, right? Salary. Okay. And then the SQL query for that, can anyone tell? Find all the details of the instructor whose age is greater than 25.
Sorry, sir. Please, can you tell once again?
Find find the all the details of the instructor whose age is greater than 25, right? So can anyone tell the SQL
Yes, sir.
statement for that?
Yes, sir.
Okay.
Select ID, name, address, salary from instructor where age is greater than 25.
Yeah, and you can see all the details means ID, name, and address, and the salary. So you can write also here ID, names. My cursor is visible, right? ID,
Yes.
name, address, and the salary. Or you can replace these things with star. Know about this syntax, right?
Yes, sir. Yeah,
Select a star from
yes, sir.
instructor where
From instructor.
age is 25. So whenever you see
Yes.
this type of means SQL query, then you can omit the pi operation, right? So here you can write you can write select age is 25 from instructor, right? So by default, it will retrieve all the information from the instructor, right?
Yes, sir.
Okay. These two operation is clear to everyone, right? So what is the pi operation as a select operation?
Yes,
Is
sir.
it pi or it is project? What is more proper?
We know this as the pi. Name of this sign is pi, but we
Yeah.
said as the project operator.
Okay.
Okay. Similar thing with this also. This is the this sign is known as sigma, but we said it's the select operator. Okay.
We should read it like the project name, where sigma is equal sigma select age project name. What should we read it in the name of SQL?
I'm
Structure of the
not able to understand.
reading.
Can you once again repeat?
Yeah. Project name where
Yeah.
age is greater than 25 in the
Yeah.
instructor table. We can
Yeah.
read like this.
No. This is an expression, right?
Okay.
So you can read out like this. So not particular way to read it.
Okay. Anyway, we can.
Yeah. So okay. Just
Your screen is not visible, sir.
yeah. I think we can discuss operator one by one. So
Yes.
so you can see here in the select. This is the select operator P predicate and the R. So select operation is clear to everyone, right? So project after we see the union operation. So you know about the union operation is the set operation, right? So can anyone tell what is the property of set property? There is one property, set property. Hello.
Which property, sir?
Questions?
Set theory, right?
Yeah.
So
Yeah.
set.
Union. This is union.
So can anyone tell what is that set property? Set not allowed the duplicate value, right?
Yeah. Union.
And whatever's inside the set, that is unordered, right?
Yes, sir.
So these things are the same thing as the whatever's in the set operation. This union operation are also the same things, right? Okay. So for the set operation, so these three are the set operation, right? This union, difference, and the intersection, right? So union. Okay. So for that, the first condition to apply this unions, difference, and the intersection, that is the numbers of columns should be same, right? Both the if suppose in just a minute. Uh, okay. So this is a new version of the Adobe. So I this problem. Can someone help me how to write on this?
Pradeep, you can open in Microsoft Edge.
Okay. Just Okay. Now it is visible to everyone, right?
Yes.
Yeah, sorry for. Okay. So you can see there are the three set operation, right? Union, difference, hence the intersection, right? So for that, these two conditions need to be satisfied. First, the numbers of rows. Suppose you want to perform the set operation between A and B. So numbers of columns should be same, need to be same, right? So A, B. So there is also numbers of columns. Means here you can see there is two columns. There's also two columns. If A has the three columns and the B has two columns, then it is not possible to perform the set operation, right? And the second condition is attribute need to be same. Means attribute data type need to be same. So what that means? So if A is the varchar, then C also have to be varchar, right? And B is int, then D has also need to be int, right? So this condition is clear to everyone, right? So first condition is numbers of attributes need to be same, and the second condition is the in orders the data types need to be same. Okay. So if these two condition is satisfied, then we can say there is a union compatibility, right? So you can
This is
perform
called
the
arity.
union.
This is called arity.
What?
Arity. This is arity. Same.
No. We said this as the union compatibility, this condition, these two conditions.
Compatibility.
Yeah. Okay. So for the union, this is the operation we denote by this cup operation, means U, like U operation. This is okay, like U. So so many of you knows that in mathematicals, if we write this thing as X union Y, such that X is belong to A. We read this out. X is such that X is belongs to A or X belongs to B, right? So you can see this operation R union S means suppose that tuples only we set all the tuples such that tuples T is belongs to either R or the tuples is belongs to S, means whichever. Okay. So can anyone tell, suppose the R union S, what will be the output? So yeah, just tell me what is the output of this.
All tuples will be the output.
All tuples means
This alpha 1, alpha 2,
Alpha 1, alpha 2, beta 1,
beta 1, beta 3.
beta 1,
beta 3.
beta 3. And why this will not?
Because it is a set
Because
operation.
it will be duplicate.
Yeah.
And,
No duplicate is
do
allowed.
not allow duplicate.
Yeah, exactly. So yeah. So
It is just like the set operations in the mathematics.
yeah, exactly. The relational algebra is just like the set operation, but the SQL means whatever write the SQL query, that is based upon the
Duplicate is allowed.
multi-set.
Yeah.
In the SQL means whatever's right in the SQL statement, right? So if we write that thing in the SQL, right? So SQL allow these things. If you try this thing in the PGN, right?
Duplicate, yeah. Duplicate will be
Then
allowed.
you get the 5 tuples, right?
Yeah.
Are you get these things? So if
Yeah.
anyone asks you what is the difference between this relational algebra and the SQL, right? So the union operation between this uh, relational algebra expression and the union operation in the SQL, right? So that is the difference. So relational algebra is very much influenced upon the set operation, and these things is the based upon the multi-set, right? SQL one. Are you getting this point?
Yes,
Yes,
what do
sir.
you mean by multi-set?
Multi-set means multi-set allows the duplicate value.
Yeah, in the SQL only, no, sir. Here,
Yeah, in SQL only.
yeah.
So here you can see the example, find all the courses taught in the fall semester or in the spring 2010 semester or in both. So here you can see. So first let me up to this part. Okay. Up to this part, how to write these things, or can you already read about the SQL statements? So can anyone tell how to write the SQL query for? Hello, someone is trying, right?
Yeah.
So this is like that's the select course. Suppose we want to select the course ID, right? So select course ID from
Courses.
course, right? Where?
Where semester equal to fall 2009.
Yeah.
Year is
Semester
2009.
Fall
fall and
and
Or.
2009.
no, not or. That is and. Here you can see the fall 2009
yes,
semester.
Okay. Yeah. Fall year. Year.
Yeah.
And year.
Then year is
year 2009.
2009, right?
You
After that we write the union operation
Union
because
operator.
of this or here you
yes,
can see. Then
Yeah.
same thing, union. Okay, repeat same thing. Yeah, select
Course ID
course ID
from course.
from course where
The semester is spring.
semester is equal to spring
And year is
semester
2010.
equal to spring and
year is equal to 2010.
year is 2000. Okay, so this thing you can same thing you can write in the relational algebra expression like this. So in the select is we define this thing inside the pi. So we write this thing pi, right? So pi course ID. Okay. So after that, in the select, whatever's inside this, right? Where condition we write under this select operation. We already discussed about it, right? So that is semester
Yeah, correct. Equal to all.
for. Okay. And by replace of and we connect with the conjunctive, right? Year 2000. Okay. From that is okay. That is from the section. Then
How
union
how,
operation.
how we will know that this year and semester is always in the section?
Which one?
Here in year and semester is
Yeah.
put in this section.
That
How
will
table is not here, sir, in the question.
that will given to you, right? So
Okay,
you need to understand only how these things are constructed, right?
Yeah.
Yeah.
Okay.
Sentence. So that is just an example.
Okay.
So in this example, you have to know only this thing, how this thing
Yeah.
is constructed.
Notations only we have.
A notation only. Okay. So yeah, then union operation, then similar thing, the pi. Course ID sigma semester equal to spring and right. So this way we performs the union operation. Next is the difference.
Sir, would you read the whole notation? How to read it?
No,
Suppose
there is
we are telling the answer somewhere. Then this is a
which
writing notation. How to read it? Project course ID or select course ID or like that.
no, this is the notation. So you can read out like this, this pi and pi course ID.
Okay.
That's it.
Anything we can either project or pi, anything we can.
Yeah. This is the notation. You only focused on the notation.
Right. But a standard reading procedure, right? So that we make a practice of that, you should read like this, because reading also makes some memory.
So yeah, right now I have no idea how to read. So you can read out like this, the select course ID.
Okay, fine. There is no standard procedure to read.
Yeah.
Okay, fine. Thank you.
And next is the difference operation. So that is the similar to subtract operation in the union set operation, right? So that is the, so suppose this two relation R and S. So R minus S means, suppose there is the tuples, one tuples, there is this one tuples. So that tuples belongs to R, and tuples is does not belongs to S. Means
Yeah.
that tuples is only to belongs from R, right? So here, can you tell me by the definition of this, what is the output R minus S?
Alpha 2 will be removed. Alpha 1 and beta 1.
Alpha 1,
Alpha 1, beta 1.
Alpha 1
uh,
beta 1.
alpha 1 beta 1, which is removed, right?
Alpha 2 will be removed.
Alpha 2 will remove because this is present here, right? But beta 1 is not present here, or alpha 1 is not present in S3. What is the definition? The tuple is belongs to only relation R, right?
Yeah.
But that tuple is not belongs to S. Okay.
Yes.
Yeah. So what will be the output? Alpha 1
Beta
and
1.
beta 1, right? So there is the set difference must be between. So same condition, because these three. So numbers of attribute need to be same. Okay. Hence the attribute domains R and S must be compatible. I already defined these two conditions, right? So union compatibility need for these three. Union, difference, and the interaction, intersection, right? So if question is like this, then you perform. Suppose the course ID taught in fall 2009 semester, but not in the spring 2010 semester, right? So whenever you can see the except or means not, right? So can anyone tell what is the SQL query for this? At least you can try. Anyone would like to try? Okay.
Yeah, sir.
Yeah. Sure.
Select the course ID.
Select course ID. The table name is section. Okay.
Yes,
From section, right?
their semester.
Where semester
Semester
is
25
and
and year is perfect. Year is 2009.
year equal to 9, right? And by minus is denoted in means
Yes, sir.
a SQL. What is that syntax is?
Except,
A keyword is except keyword, right?
yeah, sir. Except,
Yeah.
except,
Except, then
except. Select
then
course ID from section.
course ID
From section. where semester is equal to spring
where semester equal to spring
and year is equal to 2010.
and year equal to 2010, right? Okay,
Yes.
so yeah, so this thing is clear to everyone for how to write the SQL query. And second, you can see, so in the relational algebra we denotes by minus, so difference. So similar, we already see the projection course ID, then select this sigma semester equal to fall, and is denoted by consecutive. So here it's consecutive, and the year equal to 2009, and this is the relation section
Relation
minus
section.
projection course ID, and the semester spring conjunction year 2010, right? So
This is conjunctive, conjunctive
this is
or disjunctive?
this one is disjunctive, and this is the conjunctive. This is the and, right? And
Yeah.
this is or.
Or is conjunctive, sir.
No, or is disjunctive. Got it, right?
Got it.
Yes.
Yeah. So after the intersection is also the same condition. The union compatibility condition need to be satisfied. So if R and S, so R and S equal to the tuple T such that tuples T belongs to R and tuple T belongs to S. So but the tuples T is belongs from both the set, right? So
Intersection.
yeah, intersection. This is known as the intersection, but we write this thing in the SQL as the intersect, right? If you remember the intersect.
Yes.
Yeah. So can you tell me what is the output of this R intersection S?
Alpha 2.
This common attribute, right?
Yes.
Yeah. Alpha 2. So if there is one more attribute alpha 2 and the alpha 2, right?
If nothing is common,
No, no.
null.
Yeah, let me tell. Alpha 2 and alpha 2, right? Then what will the output of this
Alpha
R?
2.
Only alpha 2.
Alpha 2.
Only alpha.
Only alpha.
Yes, sir.
Yeah, okay. That is the correct answer, right? So against the answer is same for the set operation.
But what is the case, sir?
Yeah.
No tuple is in common. Pi will be there.
Which one?
If nothing is common in R and S.
Then 5.
So 5. Result
Then
will
it
be
will,
5.
yeah, 5. Empty set, right?
Okay, empty set.
Then the Cartesian product. Cartesian product is the same from the what you learned in the that mathematical, right? In mathematics. So R cross S means T is such that TQ belongs to T belongs to R and Q belongs to S, right?
Yes.
Yeah. Hello.
Yes, sir. Fine. This is just a Cartesian product, m into n. If the
Yeah,
number
yeah,
of tuples
just
are m, then m into n.
Yeah.
If m into n has the common tuple, then
Common tuples means you want to say R into R.
no, no. R
No,
into
this is R. You want to say R into R.
R into R. No, in R into S, whether it is possible that tuple will come, common tuple will come, it will not come.
The common tuple will not come.
Oh, common tuple will not come. Right. You got different R and S are different, right? Got it.
Yeah. So one thing you have to notice that the Cartesian products, the numbers of tuples. So if numbers of tuples is X and the X numbers of tuples in R in X and the Y is S is Y, then the numbers of rows. Can anyone tell the numbers of rows?
X into Y, X into Y.
X into Y, sir.
X into Y. Okay. And if the numbers of columns is M and the numbers of column is N, then numbers of M plus N is the numbers of columns.
M plus
in
N
the
is the
result.
number of columns. Yeah.
Yes.
Yeah.
If you multiply R into R, then the same number will be repeated, right? 2 plus 2 is 4. 4 columns
yeah,
will
yeah.
be there with a different name, just like SQL, right?
I'm not got. So can you repeat?
R into R. Suppose we are doing R into R.
Yeah.
Then the columns will be in the different name, like
The columns
R.
names.
RA, RB. Will be like that. What will be the name of the column? Heading.
In the sequel, you want to say in the sequel, right?
Yeah, yeah.
When we perform in the sequels, then we write this thing as the column alias, right? We provide the column alias, right?
Alias, yes.
Yeah. So let me show you that how we write. So you can write select star from R as R1, comma R as R2, right? So this, then columns will be written as the R1A, R1B, R2A, R2B.
Yeah. This is in the sequel. The same thing when you do it in this Cartesian product of the set operation, then the name will not be there like this, or the name will also be like this.
Then also we perform the rename operation, right? So without rename operation, you can't do that. So you need to be distinguished between these two.
And how will distinguish this Cartesian product in set operation?
Yeah, we will see that things in the relation rename operation, right? So if you performs to own means own cross product, right? R to R, then we write this thing as the this is row, right? This is the rename operation. So suppose the first tables R is right as the R1, right? This is R, R2. Then we perform the means
Okay, okay.
on
Not question.
cross
Okay.
product.
Renaming is this.
Renaming it, then
We'll
perform.
learn it later on.
Yeah, yeah. In the next
Okay,
slide,
okay,
I
got it, got it, got
features.
it.
Yeah. So this thing is clear to everyone.
Yes.
Cartesian product. This is simple Cartesian product. Each will multiply with each tuples of S. Each tuples of R is multiplied with each tuples of S, right?
Yes.
Okay.
Oh,
Yeah, this is the rename operation. So we write this thing as the row operation. Row, and whatever the name you want to write here, that is the X. X is the rename. After rename to the name, right? Hence E is the expression or any relation algebra relation, right?
An expression will give always a single table relation. Is it so, sir?
Yeah, yeah.
Is it correct? Then only we can select this renaming, because we can row X from the relation E. Whatever we are getting from the expression E, that will be a table. And we will rename that as row X. Is it so?
Can you repeat once again?
I'm telling this expression E will be based on the sum of set operations. And
Yeah,
this
yeah.
will give always one single table or relation. Is it so?
Yeah, yeah. It will returns an resultant set, right? So that resultant set, we want to give some name, right?
Okay, okay. That
To
resultant
refer.
set will always be a single table with some
Yeah,
attributes.
yeah.
Okay, then it is possible. Okay, fine.
Okay. After this is the division operator. So rename operation is clear to everyone, right?
Yes, sir. If the multiple attributes are there, then how to rename it separately?
Multiple.
This row X, A1, A2, A3.
Yeah, this way. So suppose there is the 3 columns, means the expression returns the 3 columns, right? Right. This is the C1, C3. Returns the expression returns these 3 columns, C1, C2, and the C3. And if you want to rename something, right? So then it is like, suppose you want to give EMP, then write ID, name, salary. Right, salary from the expression, right? This expression. So you refer this first as the C1, this one as the name. C1 is a refers as the ID, C2 refers as the name, and the C3 refers as the salary, right? And the whole is combined, whole thing is represent as this employee, right? Employee. So if you want to refer something, so if you want from project the salary, then you write this thing as the EMP dot salary, right? From this expression.
Okay, from E.
Yeah, from you rename
right.
this E, this E as these things.
Got it.
Yeah.
This is now this is an operation. This is the
Yeah.
Yeah. In the renaming, the table columns will be same. Only
Yeah.
names will be changed. Right.
Yeah.
Yeah. Okay. I see.
So after that's the division operator, right? So division operator is a represent like this. RS, R division S. So this is the one property is here. The S is a subset of proper subset of R, right? Okay.
This condition is required for the division operator.
Yeah.
S should be subset of R.
Yeah. So suppose one tables R is two attributes, right? A and B. Then add has the attribute suppose B, right? So S is the proper subset of R, right?
Yeah.
So suppose one example is 1 A 2 B 3 A, and the B has the only one value, right? B. So suppose S is the, you can take this thing as the course, means this table as the course tables. The course table has the A course and the B course, and the this one is the, simply you can assume as the this is the student ID, and these are the courses taken by the student, right? So the expression is the question is like that: find the student ID who takes all the course available in the course. So you get the question, right? The question is like find find the student ID who take all the courses. Means whenever come all or for every like this term, then we use the division operator, right? You get it, right? So here you can see the courses available A and B, and you have to find the student ID who take all the courses. So can anyone tell?
R and S are relations or tuples?
Yeah. What?
R and S. R and S
Yeah.
are relations.
Yeah, that is a relation, right? This S is a relation with B attribute, and R is a relation with A and B attribute, right?
This relation should be subset of R.
S is the should be subset of R. So B is
How can it be subset, sir? Because the number of attributes are different. Then how can we subset?
numbers of
Attributes
attributes.
are subset.
No, in term of
Number
columns.
of tuples.
In term of column, you can say. So B is present in R, right? S of B means this attribute is present in R attribute as an attribute,
But
right?
we cannot say S is the subset of R. Can we say this S is the subset of R?
S is a proper subset of R.
How? Because S is a relation, R is a relation.
No, don't go with that mathematical term. I said this is the attribute. This B is the attribute, right? And
In terms of attribute only, because attribute of S is the subset of attribute of R. Is it so?
yeah. That.
Then we should not write this S is a subset of R, because S is a relation, R is a relation. And for the
So,
subset, the tuple will be taken as a common, as I understand.
no.
What is the notation?
This is the one way in the say we say this thing.
Okay, fine.
Yeah. So now can anyone answer that? Find the student ID who take all the courses. So answer will be
1.
answer will be 1, right? So one take, here you can see A and here is the B, right? Okay.
1A and 1B.
1A and the 1B. Then answer will be 1. Okay. So
Okay.
right.
This is division.
See, this is division operation. Okay. So can anyone explain this expression?
Can we say here, sir?
Yeah.
Based on the attribute, division is just based on the attribute, the common attribute from the dividend. We can take out all the tuples which are having the same attributes. Is it so? Division is.
So yeah.
What is the sequel statement, sir? What is the sequel statement of this?
The sequel statements is the find the student ID. So
Yeah.
we always requires this. Suppose you take this as the student ID, this as the course ID, right? Okay. So the sequel statement is like find the student ID who take all the courses, right? So all the courses are present in the course table. That is, suppose S is the course table. So A and the B. A or B are the only two courses available in the course table, right? So who take means that course, right? All the courses. So only one takes the two courses. If there is the one, like one another tuples there, right? 3B, then what will be the output?
1A, 1B, and 3B.
Then no, the output will be only this one.
Okay.
So this one. So output will be the 1 and the 3 on. So if I explain these things, then you will understand.
Okay. Fine.
Okay. So so this thing understand this way, right? In simple term, I can. Okay. So suppose R is consist of A and the B attribute, right? Okay. And S is consist of B. And what is the B? And here 1A, 2B, three B, and the 1B. So this is the first tuple, second, third, fourth tuples. Okay. So first operation, we take this one, right? This attribute. only take this attribute from the R and we multiply with this. This is the expression, right? This is S and we take R minus S. R minus S means A. You're able to get it, right? R minus S means if R minus A, then only A will be there. Are you able to get it, right? So if I write pi A from R, then what will get? What you will get? Only this one.
1, 1, 2, 3. 1.
1, 2, 3, right? So my expression like 1, 2, 3. Okay.
1.
Then
1 also. 1, 2, 3, 1 also.
no.
1 B.
Hence the pi operation is the set operation, right?
Okay.
We
Okay,
eliminate
set
duplicate value.
Yeah.
Okay. Then we cross product with this one S, right? Then if we perform the cross product A, B, C, then what will be the output?
6.
6, 6, 1 A,
1
1 B,
2 B, 3 A, 3 B.
2 A, 2 B, 3 A, 3 B. Okay. After that, you can see the R minus S is A minus B. S is B, R minus S is A, right? Hello.
Yes, sir.
Yeah. So if you see this thing, this is this R expression only. This expression only. This relation only. So this is R means this, and the R minus A is A, and so S is B. So after that,
Take a fresh table, sir.
okay.
The reason is something.
Hello. Yeah.
Yeah, please.
Yeah. So after we perform this operation, we minus from that, we minus R, right? So if we minus R, then what is present in R is 1A, 2B, right? 3B and the 1.
लगा देता है मोबाइल
Yeah. Then this thing minus this
ना
thing.
लगा
So
दे
can what is the final output? So if we want to subtract these things, so you know subtract means. So whatever present in here, that should not the final output should not be present in this one B, right? So we cancel this one 1A and the 1A, right? 2B, 2B, okay. 3B cancel 3B.
1B also.
Yeah.
1B also get cancelled.
1B also we cancel. So the final output will be so
2A and
2A 3. So output of this expression pi A R cross S minus R, the output will be two A and the 3.
Here R is capital or small? The same thing.
Yeah, same thing.
Okay,
You
okay,
can
okay.
yeah, there is no difference between. You only need to understand the expression, right?
Okay.
So that is the 3. Okay. This is the output of this whole expression, right? So after So we evaluate up to this part. So this part is this one. So there is one mistake is here in the slide. So this is the parenthesis. Okay. So we want from here only we need r minus s. So r is consists of a comma b, hence the s is b, right? So r minus s means we required only this attribute, right? So that is the pi a. So can anyone tell what is the output of this one whole expression pi a this? So this is the output, right? So pi a means this is a, this is b. So pi a means 2 3, right? 2 3. This is the resultant. After evaluate this part, this whole expression 2a ends the 3a, right? Are you able to follow me?
Yes.
Right? Yeah. So pi a means we get 2 3, 2 and 3 as an output up to this expression 2 3, 2 and 3. After that you can see the pi a means these are the disqualified value. So we not that is not required, right? These are the student ID who do not take all the courses, right? But what we required, who takes all the value, all the courses. That is, if we remove from that, so takes the all the student ID. If we take all the student ID, that is the r minus s. That is a. R minus s is a, right? R minus s is a. So if r minus s, b gets the student ID, a is the student ID, b is the course ID, right? So if we take r, then we get 1 2 3, because our table is like 1a 2b 3b and the 1b. So if we select this one, then we will get, right, pi a from r. Then we will get 1 2 3. Yeah. So 1 2 3. This is the 1 2 3. Here we this expression has the output as the 1 2 3 minus whole expression, this whole expression. So what is the output of that whole expression is 2 and 3, right? So this whole expression output is 2 and 3. Okay. So if we minus 1 2 3, from 1 to 3 we minus 2 3, then output will be the 1, right? And we already got here, that's the only that student student ID 1 took all the courses, right? All the courses available in the course table, that is the 1 and 2. So I hope you got the some idea about the expression, how it is evaluated. So
The second part.
which one is the second part where you start?
R minus S. Project R
This one.
minus S, R into S. Yeah, right part.
This one.
Right side.
This one.
Yeah, this one. Yeah, a little bit confusing. Please.
exactly where can you tell? This is the first expression, right? This is first
No, where we should start? Whether we should start from the inner bracket?
we start from here. First we take from this attribute, then multiply cross product with SB attribute, right? Then we minus R attribute, this whole relation from that expression. Okay. Then we select only this A attribute from the whole expression. Okay. Okay. Let me explain once. So the table says, so suppose this is my handwriting is visible to everyone, right?
Yeah,
Yeah. This is R A B, and the table value is like 1A, 2B, 3B, and 1B, and the S is has only 2 value, right? Okay, so we need to check only those student ID. So suppose you assume that A is the student ID, B is the course ID, and this is the text table, right? Assume that things, so you can relate that things. And the S is the course ID, S is the course table, and B is the course ID, and there is 2 course available, A and B, and the A student ID takes A course, 2 student B, 2 student ID takes B course, and the 3 takes B course, and A takes B course, right? Okay.
Yes, sir. Fine.
Yeah. So first we need to, for R division S should be subset, proper subset of R. That means whatever attribute present in S, that should be means proper, need to be proper subset of that columns,
Sir,
means
S
columns
should be
or
subset of
attribute.
R, or B should be subset of AB.
Yeah.
In the expression in the slide, is given R of Z, division S of X, perhaps. Then S
Yeah.
should be subset of Z, no?
First,
Not R. S should be subset of
which
Z.
one?
Go to the slide, sir. Slide.
Yeah, in the slide. Okay.
Slide. In the definition of the division.
Y is the subset of, Y be the subset of attribute of R. Okay.
Yeah. S is the not subset of R. E R R Z division S X, perhaps it is given.
So
X is the subset of Z.
okay, let me tell you in this way these things. So whatever's attribute present in R.
Yeah.
Yeah. So at least one attribute less than that should be at least present in S. Means suppose one example. Suppose R has the attribute A, B, C. Okay.
Yeah.
So
Yeah.
S has the B, C. only B comma C attribute are there. Okay,
Yeah.
that means you can say that R is a whatever's the columns or attribute present in R, or that S is whatever's attribute present in S, that is a proper subset of attribute present in R.
Yeah, absolutely right.
Yeah.
What I am telling the same.
Yeah, now you got it.
Yeah, got it. Same thing.
Yeah.
But S is not subset of R. Why? What I am telling. Or S will be
Yeah,
subset.
we are not telling in that way.
Okay. We're just understanding.
Just understand.
Yeah, okay, got it.
Okay. So first we will take the attribute which is not the attribute not present in R, not present in S. We only select that attribute from R. So here you can see. So that's why whichever attribute that is not present in S. So can anyone tell? The attribute of R that is not present in S, that is A. A is not present in S, right? So we select that attribute from R. So what does that means? Telling. So we select S, means R minus S in the expression is given in the slide, given in the slide, that R minus S. What does that means? So here you can see R, in R present A and B. So there is B. So R minus B is A. So we select A attribute from R and we multiply with S. So whatever's attribute present in S, we multiply that. So that is A, B, and spy A is 1, 2, 3, right? 1, 2, 3. So if we perform the cross product, then output will be one A, 1B, 2A, 2B, 3A, 3B. Okay.
Yes, sir.
After that, we minus this thing, right? R
Minus R.
R. Then after minus that things, the pi R minus S comma S, or inside the parenthesis R. That means
Expression. Where is the expression?
yeah, that is the whole expression. Means simply you can, that expression we can
Sir,
simplify.
would you write this expression here so that you can understand?
Yeah, is it visible to you?
Yeah, it is visible.
Yeah. So you can see this example and you can map this thing on the slide, whatever is present in the slide. So that is exactly the same thing. Okay. So that is this whole expression, output of that whole expression is this, and the R is this thing. So if you minus this 1A, 2B, 3B, and 1B, then what will be the final output of this whole expression? So you cancel out this thing. Okay. Cancel this thing.
3B also cancel.
3B also cancel, and the 1B is also cancel.
3B will be.
Yeah. Then the final output will be 2A and the 3A, right?
Yeah.
Okay. Now let me erase this. After this thing, we get 2a and the 3a. Okay.
The whole expression. Yeah.
Yeah. The output of this whole expression is 2a and the 3a, right?
Correct.
So, yeah.
Okay, sir, fine.
Yeah. So after this, we want to select these things only, means a student ID or these attributes that is not present in S. So whichever attribute not present in S, that attribute is A, right?
Project A. Yeah.
Yeah. So that is
Yeah,
not present in S. From the whole expression, A is not present in S, right?
Yeah, correct.
Yeah. So that way, right here, the then output of this pi
2,
A
3.
2, 3. Okay.
Correct, sir, correct.
These are the
Yes.
disqualified value. Means this value are not taken.
These are qualified values, no, sir?
No, these 2, 3 are the disqualified value. Means 2 or 3 not taken all the courses available in the course table, right? So you can see 2 or 3 are not taken, all the courses are present in the course table. So A is missing for the 2 or the 3.
Yeah.
So that is the disqualified value, right? So as I previously said, the division operator is used for all, right? So whoever the student taken all the course available in the course table, right? So in that way, these are the disqualified value. So we require the qualified value. So how we get? So if we select from this A from the R expression, from the R relation here, then we will get 1, 2, 3, 1, 2, 3, right? So if we subtract this whole expression from here, the whole student ID, from the whole student ID, if we subtract this disqualified value, then we get the qualified value. Hence the qualified value is 1. So 1 took all the courses that is available in the course ID, right? You got the idea how division operator work.
Yeah.
So this is the same thing, you can check it out. Same way you can try this. Okay. I think that's in the relational algebra expression. If anyone have any other doubt, week 3 practice question.
What is RET? What is the difference between RET and cardinality?
Which one?
RET. What is the difference between RET and cardinality?
Parity. Parity means
Parity.
You got this thing in the slide, right?
Yeah, I got in the slide.
Can you tell me where it is exactly? Parity.
In the first slide only, first or second slide.
I think this is the first slide.
First or second slide. In the definition, only RET is mentioned.
Parity or the participation? Participation, cardinality, or that things are the parity. Parity means something else from and parity means something we check checks the error. Yeah.
The screen is not visible.
I'm not got you. Can you repeat once?
RIT, ARITY.
Oh, arity. Oh, sorry. Arity means numbers of
and
actions.
cardinality. I know RIT. What is the difference between cardinality and RIT?
There, cardinality means we refer to the numbers of columns, and the arity is also same thing.
That's why I'm asking. What is the difference between that? Why the two terms are being used separately?
I have no idea about.
Okay, fine.
Any
for the
other
timing we can assume we can assume that
we can assume the same thing
because
means
we should
we
understand
refer
what should
the we refer the same things, arity
Okay,
or the cardinal.
No, what is the question? Can you repeat once again?
arity, ARITY. What is the difference between arity and cardinality?
See, as far as the relation, they call the same, but arity sometimes also refers to the number of attributes in a table.
What is cardinality?
Cardinality is the participation in a relation, like that n to one to many, many to one, one to one, that kind of thing.
With respect to the set operation which we are doing, then what is the difference between the arity and cardinality? I think in the set operation it is the same now. This is my question. Okay, let us proceed.
Yeah.
Let us
1 minute.
the same thing.
Just give me a minute. I'm having some problem with my audio. Just give me a minute.
Okay. Sir, am I audible?
Yeah.
Hello.
Yeah, you are audible.
Am I audible, sir?
Yeah.
Hello. Am I audible, sir?
Yeah, can you repeat? Like I had some problem with the.
Okay. In the meantime, I think on this problem of mic and a speaker always occurs, sir, because you are the expert people are there in the IT. Whether we can identify something which is trouble-free, so that we can purchase it. Because I went to the shop, I am not able to select which one will work fine. I am best in this. Like a stand or something is recommended. This hardware is very much required. It takes so much of time, precious time of the instructor and our students also. So is it possible to identify some product which is set of products so that we can purchase it online or something like that?
No, any of this should work. Like I had a
sir,
different problem with my audio. Like
no, sir. I have made a research in the office also. All things are not working fine. Some mic is compatible with that.
no, that's basically with your computer or laptop, right? That device. It's nothing to do with your Zoom meeting or something. It's the compatibility with the hardware of your computer, right?
This compatibility is somewhere defined, no, sir. Because I have a number of devices, 2 or 3 devices. One device, the mic was of 20,000 rupees. That was working on the same PC, but the hands-free I was having, it was not working. But I was not able to understand why it is not working. It is working, but giving some disturbance, some echo, some like that.
Maybe the driver is not installed properly. That
no, driver is installed. Both is working, but quality is different. Disturbance is there, echo is there. What I'm telling, I am not expert, but I have faced this problem. But I purchased in the office 20,000 rupees. That is working fine in all. Omnidirectional mic is there, but we cannot afford this amount. But optimal thing is
like
required.
my audio device is just 300 rupees, but it is
I know,
working.
sir. Yeah, no, sometimes it makes echo and some vibration is there.
That's
happens.
basically like what I believe, like it depends on your like hardware, like your computer, your this thing.
No, sir. It is, what I am telling you, it is not depending on the computer. It is depending on the mic frequency also, because the same thing I have faced when I put that mic, a costlier mic, that is omnidirectional mic.
Okay.
So the whole problem resolved.
Okay.
The same PC. The
So
simple
I
PC.
do not know. I'll get in touch with.
Just I put this issue because experts are, we are not experts. In IIT, experts are there. They can define these things, this optimal specification will work fine. Because
We'll
experts
check
of computer, hardware, and both, the players will sit together. Electronics, computer, and this devices. They should sit together to decide which is one is best.
Okay.
This is my proposition. You got my point, what I'm telling you?
Yeah, I got the point.
Everybody is facing these problems and nobody knows. I have gone to the Nehru Place of Delhi, the top market of this. They are not aware of this thing. They are selling. Sir, you get this one, this one, this one. They are not understanding why, which one will work fine.
Okay.
This is my proposition. Just
okay, I'll check out because I didn't face this problem. So maybe, yeah.
Okay, sir, fine.
Okay, so which question we're discussing? We're discussing something.
Arity and cardinality.
Yeah. So what is the confusion?
Now it is okay, sir, because we cannot define properly. So we can understand arity and cardinality for the set is the same for the relation. Is it so?
Yeah. But what I told in many cases, like arity also says the number of attributes in a table. Like arity of a table is this.
Yes.
Okay. So next.
Okay, fine. Let us proceed. No problem.
Any other doubt regarding activity question or the practice question? I think that.
Yeah, Pradeep, I think nobody having any.
Yeah. So I think that's it for today's session. Thank you. Thank you, everyone.
Thank you.